whenever the natural number will be added to 0, it will become whole number. Set of integers is denoted by the letter Z. The number which is having the factors other than 1 and itself, that is going to be known as the composite number. It is ending with the even number? No, it is ending with the odd number. So odd prime, it will start from 3. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In this session, we are going to study the chapter 1, which is nothing but the number theory. Okay, basic maths number theory chapter 1. What number theory will be useful in day-to-day life? Especially for bank transactions, it will be very useful. Okay, this is a keyword you are going to remember, and this is going to be known as the public key cryptography. Okay, so in these field, especially in the banking sector, we are going to use this number theory, as well as in the logarithms also we are going to use this number theory, as well as in programming also we are going to have this number theory advantages. Now let me look into what are the fundamentals or what are the topics you are going to study under this number theory. Here we are going to talk about introduction to the number system. So what do you mean by number system here? And then you are going to have what are the numbers you are going to see under the number system. And then we are moving on to the fundamental theorem of arithmetic, okay, which will be used to find out the sum of divisors and the number of divisors. And then we are going to have the problems based on this fundamental theorem of arithmetic. Okay, now let us move on to the number system. First, you are going to have in this chapter, we are going to study about the numbers and their properties and the applications. Okay, applications means the formulas where you are going to use in the problems. Okay, first we are going to have natural number. What do you mean by natural number? Natural number is nothing but the counting number. How we are going to count? We are going to count like it will be starting from 1, 2, 3, 4, etc. like that, isn't it? That's what itself is the natural number. Counting numbers 1, 2, 3, 4, etc. It will go up to an infinite terms, that is undefined, that are going to be known as the natural numbers. Okay, and they are also called as positive integers, which is denoted by the letter N, and it is written as within the flower bracket and separated by a comma until where infinite. Infinite we are not going to write it here symbolically, but we are going to represent by dotted form. Okay, that is nothing but it will move on to infinite number of terms. Got? And then we'll be moving on to what do you mean by the whole numbers. Whole numbers means whenever the natural number will be added to 0, it will become whole number. So here all the natural numbers together along with the 0 form whole numbers. If 0 is added to any natural number, then it will become, what is that? Then it will be giving you the same number. For example, you know, these are all the natural number. If I am going to take it as 0 plus 3, what you are going to get it as? 3 only. Or if I am going to do it as 3 plus 0, the same number 3 only are going to get it as. In general, it will be n. N can be replaced by any natural number. So, I have written in general 0 plus n or n plus 0. You can take the example of these. Will be giving you n itself. Where n belongs to where? It will be belonging to the natural number. Got? This is a special case of the whole number. Then how we are going to denote the whole number, ma'am? We are going to denote the whole number by the letter W, and then we are going to write the elements inside the flower bracket separated by a comma, which is 0, 1, 2. It will go up to infinite number of terms. Understood? Next we'll be moving on to the integers. Ma'am, what do you mean by this integers? Set of all positive numbers, set of all negative numbers, along with the 0, you are going to have it as set of all integers. Here, all positive integers, all negative integers together with 0 is going to be called as set of integers, and set of integers is denoted by the letter Z. And we are going to write the elements of Z as like. First we are going to write it as 0 here. Right hand side of 0 always the positive integers you can observe, and the left hand side of 0 always it will be a negative integers. Okay, so therefore together it will be forming the set of integers. Got? Next we'll be moving on to what? See here, odd and even integers. The integers which are 1, 3, 5, 7 are called odd integers. The integers which are 0, 2, 4, 6 or -2, -4, -6. Here also you can include -1, -3, -7, -5 are also odd integers, but negative odd integers. Here you can observe positive even integers, and these are and all negative even integers are called even integers altogether. So here you can observe 1, 2, 3, 4 as I told. Positive integers, -1, -2, -3, 4 are called negative integers. But here both positive, odd and even integers are included. Both here odd and even integers are included. But 0 cannot be called as neither the positive nor the negative, or we also assume that it is neither even nor odd. But in some cases we need to consider, according to the situations of the problem, 0 can be taken as the even integer. So that only I have mentioned here. Okay, according to the situations of the problems. Next we'll be moving on to the prime number. This is very, very important. What do you mean by prime number, ma'am? Here I have taken an integer p which will be always greater than 1. Greater than 1 means what? It will be a positive integer here, and then is said to be a prime number if it has no other divisors except, this is very important, except 1 and itself. For example, if you take it as 3 can be divided by 1 and divided by 3 itself. If you are going to divide it by other number, you are going to get it as fractions. If you divide it by 4, if you divide it by 6, 3 by 6 nothing but 1 by 2, correct now? So therefore here the number which is divided by 1 and itself is going to be known as a prime number. Some of the prime numbers are 2, which is divisible by 2, and also it will be having 2 will be having only 2 factors, that is 2 and 1 itself. That is you are going to have 1 and 2. The number itself you are going to have the divisors. Okay, similarly 5 which can be divisible by the same number and 1 itself. 7 which is divisible by the same number and 1 itself. No other factors you are going to have for all these kind of numbers. These are all going to be known as the prime numbers. Okay, note that 2, you know already 2 is the even number, but here since 2 is divided by 1 and itself, we are going to call that one as even prime number. This is only the number we are having even prime number. All are nothing but, you can observe 3, 5, 7, 11 are nothing but the odd primes. Okay, that means prime numbers. And prime numbers are what? they are infinite. You can continue also as like 13, 15, you are going to have 17, correct? You are going to have like that. Next, we'll be moving on to the composite number. What do you mean by composite number? The number which is having the factors other than 1 and itself. That is going to be known as the composite number. An integer which is not a prime number, you can also call as like, is going to be known as the composite number. For example, 4. 4 will be having the factors what? Only not 1 and 4. It is also having 2. 2 into 2 is nothing but 4, isn't it? See, 4 can be divisible by 1. 4 can be divisible by 4. 4 can be divisible by 2. So, how many factors it is having? It is having 1, 4 and 2. So, if it is not a prime number, then it is a composite number. Prime number means which is divisible by 1 and the number itself, right? So, next will be having 6. 6 can be divisible by 1, divisible by 2, divisible by 3, correct? So, and also 6 can also be divisible by 6. See, you can observe these many factors you are having for a 6. So, it is a composite number as well. You can move on. These are all going to be known as the composite number, and composite number also infinite. And then a composite number n has a divisor other than plus or minus 1, plus or minus n. As I told you here, you can take the examples of these two. Okay, other than plus or minus 1 and other than this is, you can leave this and this. Other than this also it is having 2, it is having 3, isn't it? You can leave this and this. Other than 1 and itself it is having 2 also divisor. So, generally we are going to take it as plus or minus 1 and plus or minus n. You have to note that 0 and 1 are neither prime nor composite, because it will be used in prime number also, it will be used in composite number also. So, we are going to call that one as it will be neither prime nor a composite number, which are 0 and 1. Next, we'll be moving on to very important fundamental theorem of arithmetic. What do you mean by this, ma'am? Observe here, every composite number means which will be having the divisors other than plus or minus 1, plus or minus n, isn't it? That is going to be known as the composite number. That can be expressed as product of primes. It can be expressed as product of primes, and this decomposition will be unique. Okay, and then apart from the order in which the prime factors occurs, apart from the order you are going to check it out, prime factor will be occurring. That is going to be known as the fundamental theorem of arithmetic. Now, what is the example, ma'am, I can take here? I have taken a simple example which is nothing but the factors of 35 are. What are all the factors? What are the divisors? 5 into 7. So, we are going to rate it as 5 power 1, 7 power 1. Isn't it? What is 5 power 1? 5 power 1 is 5 only. What is 7 power 1? It is 7 only. Correct? 5 into 7 gives you the 35 number. Next, we'll be moving on to the prime factors of 24. Will be 2 cube into 3 power 1. What is 2 cube? You are going to write it as 24 can be written as what? You are going to have it as 8 into 3, isn't it? You are going to 8 into 3. See, 8 into 3. What this 8 can be written as? 8 is nothing but 2 into 2, isn't it? You are going to have it as 2 into 2 into 2. See? This into 3, which is nothing but 8, isn't it? And then 2 into 2 into 2 is nothing but what? You are going to have it as, which is 2 power 3, which is 3, correct? So, 2 power 3 into 3 gives you what? 8 into 3, which is nothing but the 24. Next, we'll be moving on to the prime factors of 28 are. What is that? you are going to have it as 7 4s are 28, isn't it? So we are going to take first is nothing but the 2, which will come starting number, and then we are moving on to the higher number. 4 7s are 28. That 4 can be written as what? 4 can be written as 2 into 2, which is nothing but 2 squared. So this is how we are going to represent the prime factors. I'll tell you how the prime factors are find out by taking the next numbers of what? The LCM and then HCF method. Okay. Next we'll be moving on to this kind of, see, this kind of representation is going to be known as factorization, or it is going to be known as canonical representation. This type of question will be asked for 1 marker in your final examination. Got? Next we'll be moving on to the above theorem. This is the formula part. That means application level. The above theorem means the fundamental theorem of arithmetic can be applied to find out what? The number of positive divisors. Okay, and then sum of all positive divisors. You have to observe here sum and the number of positive divisors and the sum of all positive divisors of a given number. Got? Now how we are going to have the formula for number of divisors, that means positive divisors, and the sum of all positive divisors, ma'am? We'll move on to that. Let n be a composite number. Got? We know that any composite number can be expressed as what? Product of primes. As you know here, it can be expressed as what? The product of primes. Therefore, let n is equal to, dear students, observe here, we have taken what? 2 power 3, 3 power 1, 5 power 1, 7 power 1, 2 squared, that is 2 power 2, 7 power 1, like that. So, therefore, I am going to consider these numbers in generally as P1 power alpha 1, P2 power alpha 2, as like you know, that is P1 power alpha 1, P2 power alpha 2. Powers I am going to represent as alpha 1, alpha 2, alpha 3, and the numbers I am going to represent it as P1, P2, P3. Got? So therefore, where this P1, P2, P3 are what? Distinct primes. Distinct prime means it will be what? The number and itself. It will be divisible by number and itself. So let T of n denote the number of positive divisors. Okay? Positive divisors of n, and S of n denote the number of sum of all positive divisors. It will be denoting sum of all positive divisors of n. Then what is the formula, ma'am? We are having T of n. That is, what is the number of positive divisors can be given by the formula 1 plus alpha 1. See here. 1 plus alpha 1, be careful here, into 1 plus alpha 2, into 1 plus alpha 3, it will move on to where? Up to 1 plus alpha n. Okay? N means number of divisors, what you are going to get, it will end to that. Next, sum of all divisors, it is given by the formula, see, P1 power alpha 1 plus 1 minus 1 divided by P1 minus 1 into P2 power alpha 2 plus 1 minus 1 divided by P2 minus 1 into P3 power alpha 3 plus 1 minus 1 divided by P3 minus 1, etc. up to where? N number of terms. That is Pn alpha power alpha n plus 1 minus 1 divided by Pn minus 1. So this is a formula for number of positive divisors finding, and this one is the formula for sum of all positive divisors you are going to have it as. Next, let us move on to how to apply this formula for the given problems. First, I have taken here find the number of divisors of the following number. So let me take this one. Find the number of divisors of the following number 672. Let me do this problem first. What is that? 672. So how to find out the prime for this one? We are going to have it as 672 can be divisible by what? Divisible by 2, because you are having the last number is 2. If the last number is 2, that means even numbers, it can be divided by even number. So therefore I am going to take it as 2, correct? 2 3s are 6, and then you are going to have 2 3s are 6, 1 is carry over, so you are going to have it as 2 6s are 12, correct? Next you are going to have, again 6 is an even number, so it can be divisible by even. So you are going to 2 1s are 2. 2 1s are 2 is 1 is remaining. It will be carry over, which will become 13. So 2 6 are 12. 2 6 are 12. Again 1 is carry over, which will become the last number is 16. Correct? So carry over, you can write 1 and 1 year carry over, right? So again 16 means you are going to have it as 2 8s are 16. Again 8 is an even number which can be again divisible by 2. So therefore I am going to take 2 again. So here you can observe 1. 1 cannot be divisible by 2. So therefore you are going to take that carry over, that is 16. So 16, 2 8s are 16 you are going to have it as, isn't it? Again 2 4s are 8 you are going to, isn't it? But dear students, when you are multiplying, be careful that 336 into 2 exactly giving you 672. That you have to check out. See, 336 into 2. Multiply if you want. 2 6 are 12. 1 is carry over. 2 3s are 6. 6 plus 1 is 7. Again, 2 3s are 6, correct na? So it is giving the number 672. It is giving the number 672 when you are multiplying by 2 again. Similarly, you have to check when you multiply by 2 with 168, it is giving you 336. That you need to check out. Okay. Similarly, you have to check out when you multiply by 84 into 2, it is giving 168. Let me check out here. What is that? 84 into 2. Correct. 2 4s are 8. Again, 8 2s are 16. Correct. It is giving the number 168. That is 2. Like that only you have to do for all the numbers here. So you have to recheck for the numbers. So next, again it is an even number. So therefore it can be divided by even. So 2 4s are 8, 2 2s are 4. Again it is an even number. So therefore 2. That means ending with 2 is an even number, right? So 2 2s are 4, 2 1s are 2. Correct? Next, again it is an even number? No. It is ending with what? It is ending with 1. 1 is not an even number, it is an odd number. Which is an odd prime you can have? 3. Next to 2, it will come 3 only. Ma'am, why can't we take 5? So we cannot leave 3 and go 5. If it is not divisible by 3, then we can go for 5. So here we are going to have 3. 3 7s are what? 21. Again 7 is the prime number. 7 is only the prime number which is divisible 1 and 7 itself. So therefore you are going to stop here. That is 7 1s are 7. So these are all the factors you are going to have for 672. So how I can represent 672, ma'am? 672 can be represented as, see, 2 into 2 into 2 into 2 into 2. So 2 one time, 1 2 3 1 2 3 4 5. 1 2 3 4 5. Next you are going to have it as what? 3 7. Correct? So therefore now how many times you are having 2? 5 times. So you are going to have it as 2 power 5. How many times you are having 3? Only one time. 3 power 1. How many times you are having 7? Only one time. 7 power 1. All this multiplication gives you the number 672. You can multiply, okay? 2 power 5 into 3 power 1 into 7 power 1 gives you 672. So therefore, this is nothing but you can observe, dear student, which is in the form of P1 alpha power 1, sorry, P1 power alpha 1 into P2 power alpha 2 into P3 power alpha 3. You can observe what are all the powers? Alpha 1, alpha 2, alpha 3. What are all the numbers? 2, 3, 7. Okay. So P1, I can write it over here. What is that? P1 you are going to have. See, here I am going to write it as P1 is nothing but 2 and alpha 1 is nothing but 5. Similarly, P2 is nothing but, what is that? You are going to have 3 and alpha 2 is nothing but 1. Similarly, P3 is nothing but 7 and alpha 3 is nothing but 1. Correct? So you need to observe this. Then what they have asked? Number of divisors. What is the number of divisors formula you are going to have? So you can have it as the number of divisors. Here I am going to write it as, see, here I am going to erase this. And then I am going to write the formula, which is nothing but, what is the formula you are having? T of n is given by, what is that? 1 plus alpha 1 into 1 plus alpha 1 into 1 plus alpha 2, etc. 1 plus alpha n. But what we are going to write it here? How many alpha 1, alpha 2? There are 3 alpha. So we are going to restrict it to 3 alpha. What is that? So therefore, T of n is equal to 1 plus alpha 1 into 1 plus alpha 2 into 1 plus alpha 3. Right? So what is alpha 1, alpha 2, alpha 3? You are going to have it as 1 plus alpha 1 is 5. Alpha 2 is 1, alpha 3 is also 1. Substituting that, 1 plus 5 into 1 plus 1 into 1 plus 1. Correct? So therefore, you are going to have it as 1 plus 5 is 6 into 1 plus 1 is 2 into 1 plus 1 is 2. So you are going to have 6 2s are 12, 12 2s are 24. So T of n, you are going to have, the answer will be 24. Understood? Next we'll be moving on to, this is an easy level problem I have taken. Next we'll be moving on to the next problem. Find the number of divisors. You are going to have it as 4896. Now let me do the prime factorization. What is that? 4896 can be divided, since 6 is an even number, at last it can be divided by even number. Even prime number is 2 only. So 2 2s are 4, 2 4s are 8, 2 3s are 6, 1 is carry over, correct? 2 4s are 8, 2 2s are 4, 2 4s are 8, 2 4s are 8, 1 is carry over. So you are going to have it as 2 8s are 16. Dear students, multiply 2, 4, 4, 8 along with the 2. It must gives you the number 4896. Got? Next we will be moving on to, again, the number ending with the 8, which is an even number. It can be divisible by 2. That is 2 1s are 2, 2 2s are 4, 2 2s are 4, 2 4s are 8. Correct? Next again, it is an even number ending with 4. So therefore I can take it as 2. See here, what is that? 1 can be carry over. 1 cannot be divided by 2. So I am going to carry 1 to 2. It will become 12. So what it will be? 2 6 are this one. 2 6 are 12. Again 2 1s are 2. 2 2s are 4. Correct? Dear students, observe here. The starting number only I am going to get carry over. So I am writing 12 as 2 6 are 12. Again 2 1s are 2. 2 2s are 4. Right? Multiply and check out. 612 into 2 must give you 1 2 2 4. See here, 2 2s are 4. Correct? 2 1s are 2. Again 2 6 are 12. Right? So it is giving you 1 2 2 4. Therefore multiplication is proper. So next you are going to have, again 2 is a even number ending with again 2. Correct na? 612. I can take it as what? It will be divisible by 2. That is 2 3s are. Now it is a problem here. You are going to take carry over 12. Correct? If you are going to take carry over, it has, because 1 cannot be divisible by 2. Right? So what you are going to do? As like here, you are going to take it as here 12. 12 is divisible by 2, which is 6. But observe, 36 into 2 is giving you 612. No. So let me multiply here. 36 into 2. 2 6 are 6 2s are 12. 1 is carry over. 2 3s are 6 plus 1 7. Correct? It is giving you 72. It is not giving you 612. So what you need to do? 0 is a carry over here. And then you are going to have 2 6 are, it is 12. Now you can observe, dear students. Okay? So 306 plus 306, obviously it will giving you 612, or 306 into 2 is 612. So again we'll be moving on to the next. So it is ending with the number 6. Again it is divisible by 2 only. So 2, you are going to have 2 1s are 2. 2 1s are 2. 1 is getting carry over here. So it is 10. So you can have it as 2 4s are 8. Isn't it? 2 4s are 8. Or you can have it as 2 5s are 10 directly. And then 2 3s are 6. Isn't it? Again, it is ending with the even number? No, it is ending with the odd number. So, odd prime, it will start from 3. So, 3 you can have it as 1. You can take carry over to 5 directly because it is starting. So, 15 if you, because 1 cannot be divisible by 3. Only 15 can be divisible by 3. So, 3 5s are 15. Again, 3 1s are 3. Please check, dear students, 51 into 3 gives you what? 153 only. 3 1s are 3, 3 5s are 15. Again, it is the odd number in the ending. So, it is divisible by 3. So, you are going to take it as 3 1s are 3, 3 2s are 6, it will go beyond. So, 3 1s are 3, it will be carry over here. How many carry over? 2 will be carry over. So, this will become 21. So, 3 7s are 21. Are you having any number which is divisible by, it will give you the number 17? No. Other than 17, it cannot have any other number because it is a prime number. So, therefore, you can have the last number is 17 into 1, which is 17. So, what are all the prime factors? You can write it as, therefore, 4876, 4896, not 76, 4896 can be written as, what is that? 1, 2, 3, 4, 5. So, I am going to write 1, 2, 3, 4, 5 into 3 into 3 into 17. Right? You are going to have. So, how many 2s you are having? 1, 2, 3, 4, 5. So, you are going to write it as 2 power 5 into, how many 3s you are having? 3 into 3, which is 3 power 2, 3 squared. Next, you are going to, how many 17 you are having? Only 117. So, therefore, 17 power 1, which is in the form of what? You can have P1 alpha power 1 into P2 alpha power 2 into P3 alpha power 3, P3 power alpha 3, P1 power alpha 1, P2 power alpha 2, P3 power alpha 3. Correct? So, therefore, you can have the formula of Tn as what? What is Tn? Tn will be is equals to 1 plus alpha 1. I can stop till 3 only because you are having till alpha 3 into 1 plus alpha 2 into 1 plus alpha 3. Right? So, therefore, you can have alpha power 1, which is nothing but 5, alpha 2, which is nothing but 2, alpha 3 is 1. So, therefore, 1 plus 5 into 1 plus 2 into 1 plus 1, which will be giving you 1 plus 5 is 6 into 1 plus 2 is 3, 1 plus 1 is 2. You can have here, what is that? 6 2s are 12, 12 3s are 36, isn't it? Correct? So, this is your answer, or 6 3s are 18, 18 2s are 36. Got? So, next we'll be moving on to the type of problem. Here you have to observe this especially, okay? This is very important. You multiply and check out whether the same answer you are going to get it. What is that? The behind number, what you are going to, should be getting as the same when you multiply by that or divisible by that number. We'll be moving on to the next problem. Find the number of divisors of the following number, which is 103. 2, 4. We'll be doing the prime factorization. 1, 0, 2, 4. Since number ending with 4, what we can take? It can be divisible by even prime. Which is even prime? Only 2. So therefore I can have 2. See, 1 cannot be divisible by 2, but carrying over 10 can be divisible by 2. 2 5s are 10. 2 1s are 2, 2 2s are 4. 512 plus 512, obviously 1024 only. Or 512 into 2 is 1024 only. So again, ending with the 2, which is an even number, again it can be divisible by 2 only. Now 2 2s are 4, 1 is getting carrying over. Right, so 1 will become 11 now. So 2 5s are 10. Again 1 is getting carry over. Correct. Again 12 means 2 6 are 12. Again ending with the even number, which is 6. Again you are going to have 2 1s are 2. 2 2s are 4. 1 is getting carrying over. 2 8s are 16. Again ending with 8, which is an even number. So 1 cannot be divided by 2. So we are going to take it as 12 together. So we are going to have 12, which is nothing but 6 2s are 12. Correct. Again 2 4 2s are 8, or 2 4s are 8. You are going to have is 64 into 2 is 128. Check out. 2 4s are 8, 2 6 are 12. Obviously it is 64 plus 64 is 128 only. So next again it is ending with a 4, which is an even number. Again even prime, divisible by 2 3s are 6, 2 2s are 4. 32 into 2 is 64 obviously. Again 2 1s are 2. Correct. 1 is getting carry over. So you are going to have 12, which is nothing but 2 6 are 12. 16 into 2 is 32 only. Perfect. Again 16 is an even number. Again it is divisible by 2. 2 8s are 16. Again 4 is an even number. So 2 4s are 8. Again 4 is an even number. 2 2s are 4. Again 2 is an even number. 2 1s are 2. How many 2s you are having? Calculate. So 1 0 2 4 can be written as 1 2 3 4 5 6 7 8 9 10 11. Correct. So see here, I'm going to write it as 1 2 10 na? 1 2 3 4 5 6 7 8 9 10. 2 into 2 into 2 into 2 into 2. 1 2 3 4 5 6 7 8 9 10, which is nothing but 2 times power 10. Now which is nothing but in the form of P1 power alpha 1. Only one number you are having, no other than that. So therefore what is a T of n? T of n formula is only one number, 1 plus alpha 1, which is nothing but what? 1 plus 10, which is 11. This is your answer. Got now? So how you are going to do? What is that? The divide sum all the divisors, positive divisors, that is T of n. So this is how you are going to find out the number of positive divisors. Next we'll be moving on to find the sum of positive divisors of the following, which is 6 4 9 8. So next we'll be moving on to again the prime factorization, which is divisible by 2 prime, because prime number which is now ending with the 8 is a even number. So 2 is only the even prime. 2 3s are 6, 2 2s are 4, 2 4s are 8. 1 is getting carry over. 2 9s are 18. Correct? Next you are moving on to again, is 9 is a prime number? No, it is an odd number. So what you are going to do? You are going to check with 3 now. So what is that? 3. 3 1s are 3. Again 2 cannot be divisible by 3. So you are going to take it as carry over. So what you are going to get it as? See, 24. 24 is nothing but 8. Correct? 0. You are going to take it as 24 is 8. 2 8. 3 8s are 24. Again 3 3s are 9. Dear students, observe here what I have done. Okay. So here 1083. 1083 into 3. 3 3s are 9. 3 8s are 24, which is 4. Again 2 plus 0 is 2. Again you are going to have 3 1s are 3. 3 2 49. It will be giving you the same number. But if you write it as your 183 into 3, it will never give you this number. 3 3s are 9, 8 3s are 24. Again 3 1s are 3, here 2 is carry over, 3 plus 2 is 5. It will be giving you 549, which is wrong. It must gives you this number, so 0 you have to take it as carry the number. Got? So again you are going to have it as, again 3 is a odd number, so it can be divisible by again 3. So I can have it as again 1. Now 1083, see dear, carry over you are going to take it as 3. It can be because odd number, so 3 1s are 3, again 0 is 3 8s are, again 3 3s are, right? So again it is divisible by 3, so 3 3s are 9, 3 4s are, what is that? Carry over you are going to have, which is nothing but the 18. So 3 6 are, which is nothing but 18. Next you are going to have it as 3 1s are 3. Now check it out. It is divisible by 3. No. If you take it as 3 1s are 3, 3 2s are 6. 1 cannot be divisible by 3. So 4, it cannot. 5, no. 5, again 1, it will be remaining. So it will be divisible by 19. Okay. So you can check it over here. It will be divisible by 19 only. Okay. What is 19 into 19? Let us multiply here. You are going to take it as, what is that? 19 1s are 19 19s are. So therefore again 19 1s are. Got? So next you are going to have it as, which can be 6498, can be written as what? So I am going to write it as 6498, which will be is equal to 2 power 1 into 3 power 2. I am going to write it directly into 19 power 2, which is like P1 power alpha 1, P2 power alpha 2, P3 power alpha 3. Got? So alpha 1 is 1, alpha 2 is 2, alpha 3 is 2. But what they have asked? Sum of all. What is the sum of all positive divisors? You are going to have S of n will be is equal to P1 power alpha 1 plus 1 minus 1 divided by P1 minus 1. Correct? Up to Pn power alpha n plus 1 minus 1 by Pn minus 1. But here only till 3 is there. I am going to write till 3 into P2 power alpha 2 plus 1 minus 1 divided by P2 minus 1 into P3 power alpha 3 plus 1 minus 1 divided by P3 minus 1. Now let us substitute here. What happens? Let us check out. What is that? P1 power alpha 1. You can write it as here. So erase this and then you are going to have it as here, the formula substitution, which is P1 to the power alpha 1 plus 1, which is, you can write it as, what is P1? P1 is 2, alpha 1 is 1. So 2 S of n will be is equal to 2 to the power alpha 1 plus 1, 1 plus 1, 1 plus 1 minus 1 divided by 2 minus 1 into, again P2 is nothing but 3 to the power of alpha 2 is 2 plus 1 minus 1 divided by 3 minus 1 into P3 is 19. So you are going to have it as, what is that? 19 to the power of 2 plus 1 minus 1 divided by 19 minus 1. Correct? So therefore you are going to write it as 2 power 2 plus 1. What is 2 power 2? I am going to write it here. 2 power 2 minus 1 divided by 2 minus 1 into 3 power 3 minus 1 divided by 3 minus 1 into 19 power 3 minus 1 divided by 19 minus 1. So therefore 2 power 2 is 4 minus 1 divided by 2 minus 1 is 1 into 3 power 3, which is nothing but 27 minus 1 divided by 2 into 19 power 3, 6859 minus 1 divided by 19 minus 1 is 18. Correct? Next you are going to have it as 3 by 1 is 3. You are going to have 3 into 26 by 2 into 6859 minus 1 is 6858 divided by 18, correct? If you do this one, you are going to get the answer. Please check over the answer here. If you multiply, you are going to get the answer as, which is 3 into 2 ones are 2, 13, again 381. Now you are going to get the answer for this one as 14,859. Okay, this is your answer. 859. 859 is your answer. Okay, dear students, I think you understood this class, how to find out the sum of all positive divisors and then the number of positive divisors and fundamental theorem of arithmetic. Thank you, dear students. We'll meet in the next session, solving more problems. Thank you.